Hi everyone. This is the first in a series of a couple videos on visualizing set expressions using Venn diagrams. This video will focus on the basics. A Venn diagram is a tool used to depict sets or represent sets. In a problem, a universal set or the universal set is a set of all elements under consideration in the problem. For example, if we're focusing on a problem involving integers, the universal set might be the set of all integers. A, which is depicted by the circle within the universal set, is typically a subset of the universal set. So in this case, A might be the set of even integers. Using Venn diagrams, you can depict sets and operations on sets. So for instance, the set I have down here, the first operation, I should say, is complement. So what is the complement of a set? X is in the complement of the set, which is represented as A with a slash or a dash. And if you're in computer science, that would be A with a bar over top. So X is an element of the universal set, of a complement, if X is in the universal set, but is not in the set A. So in this case, visually, that would be everything that falls in the universal set, but falls outside of set A. So this shaded region here is the set A complement. In this case, if we're go back to the story of integers, if A is a set of even integers, then the A complement would be the set of odd integers. The next sort of set of basic visualizations are of the union of two sets and the intersection of two sets. And union and intersection are defined in terms of their logical connectives. So X is in the union of two sets. X is an element of A union B, in other words. If X is either an element of A or X is an element of B. Now recall from logic that an OR statement is true if one or the other or both statements are true. So if X is in A, then it's in A union B. If X is in B, it's in A union B. If X is in both A and B, it's in A union B. So A union B would be represented by everything in the two circles. So you've got that region is A union B, that region is A union B, and this region is A union B. You can think of it almost as the addition of the areas. The set intersection, which is represented by this upside down U, is defined in terms of AND. So X is an element of A intersect B, if and only if X is in A and X is in B. And recall that an AND statement is only true if both are true. So if X is an element of A, which would be represented like this, X is an element of B would be represented like that. So in which region is the AND statement true? X is in A and X is in B. That would be this little region right here. Some students call it the football in the set diagram. So that region would be A intersect B. The final basic representation is of set difference, is what many people call it. Technically, it's the complement of A relative to B. Okay, so X is an element of A minus B, if and only if X is an element of A and X is not an element of B, which you could also say X is an element of B complement. Okay, so if it's an element of A and it is not an element of B, that would be this region right here. So that region would be A minus B. Another important definition in sets is the notion of disjoint sets. For disjoint sets, the intersection of A and B is empty. In other words, there are no elements that A and B have in common. If you know the sets are disjoint, you can represent them as separate circles, as in the diagram on the right. In the next video, we will focus on some more complex set expressions and an introduction to proof using sets.